Hello grade 12s and welcome to another lesson under physical sciences in the topic of matter and materials. Right now, even though you're not supposed to know this, but we're going to be dealing with elimination reactions. So the types of elimination reactions that we're going to be dealing with, they are listed below. We have dehydrohalogenation, which is the removal of a hydrogen atom and a halogen atom from a compound. Then we have dehydration, which is the removal of a hydroxyl group and a hydrogen atom from a compound. Then we have dehalogenation, which is the removal of two halogen atoms of the same element from a compound. Then we have dehydrogenation, which is the removal of two hydrogen molecules from a compound. Please take that down. I modified it from siavola.com. So number 1 states, what do we call the removal of a halogen atom and a hydrogen atom from a saturated compound? Forgive me. So halogen and hydrogen, this is dehydrohalogenation. Number 2 states, what do we call the removal of a hydroxyl group, OH, and a hydrogen atom from a saturated compound? That's called dehydration. So number 3 states, consider the following chemical reaction. We have 1 iodo propane reacts with potassium hydroxide and energy to give product A and potassium iodide and water. So we need to make this reaction clear, right? Okay. So we have, first we draw one iodopropane. So this is going to be let's put the I here. It reacts with potassium hydroxide, right? To form, we don't know what product A is, but potassium iodide. So this is gone, this is gone. So when this goes, we know that a double bond has to form, right? So it will form here, and then we'll have to eliminate one hydrogen atom. So this goes, right? But the hydrogen atom that we eliminated goes to the OH and it becomes water. So this is product A. Okay, we'll name it. So 3.1 states, to which homologous series does one iodopropane belong? We know that one iodopropane it belongs to the haloalkanes or the alkyl halides, right? And then 3.2 states, draw the structural formula of one iodopropane. So it's the original formula without the alterations, using my pencil there. Here's iodine. So there is one iodopropane. So 3.3 states, what type of reaction? Remember you had options on the laptop: addition, elimination, or substitution. So we took iodine and hydrogen, right? So this is an elimination reaction. Then 3.4 states, give a reason for your answer in 3.3 above. And I just mentioned the reason. And the reason is a hydrogen atom and an iodine atom were removed from the haloalkane to form an unsaturated compound. Hope that makes sense. 3.5 states, give the IUPAC name of product A. So here's product A. These are gone, right? There's a double bond. So 1, 2, 3. This is propene. And then 3.6 states, to which homologous series does product A belong? Propene is an alkene. So this belongs to the alkenes. 3.7 states, name the type of elimination reaction taking place. Remember we removed iodine, which is a halogen, and hydrogen. So this is dehydrohalogenation. here to halogenation. And then 3.8 states, draw the structural formula of product A. Okay, here it is, I just did that. Remember, without the pencil, we removed these. Okay, I hope. So that's propene. Hope that wasn't too hard. And then number 4 states, consider the following chemical reaction. Butane 2-ol under the influence of that catalyst forms product A and water. Right? So Roman numeral number 1 asks, to which homologous series does butane 2-ol belong? It belongs to the alcohols. Okay. Roman numeral number 2 states, draw the structural formula of butane 2-ol. So but, we know that we have a 4 chain. 1, 2, 3, 4. 4 carbon chains, right? 1, 2. Position number 2, we have a hydroxyl group. So that is butane 2-ol. What type of reaction is this? Once more, you were given options: addition, elimination, or substitution. So we can see one reactant splits up to form 2 products, product A and water. So this is an elimination reaction. Roman numeral number 4 states, is butane 2-ol a saturated compound or an unsaturated compound? As we can see, single bonds only, so it's a saturated compound. Roman numeral number 5 asks, is butane 2-ol a primary alcohol, secondary alcohol, or tertiary alcohol? Where's the hydroxyl group attached? It's attached to this carbon. This carbon is a primary secondary. The secondary carbon atom. So butane 2-ol is a secondary alcohol. Then Roman numeral number 6 states, name the type of elimination reaction taking place. So we've removed H2O. So we removed the hydroxyl group, right? What else? And a hydrogen group. So this is a dehydration. Okay, and then Roman numeral number 7 states, write down the IUPAC name of product A if it is a major product. Major products and minor products. So we need to understand so we removed H2O. First we remove this hydroxyl group. Right? So when we remove it, this bond goes away, right? Meaning a double bond will have to form. And we remember it forms with the least substituted carbon atom. So is it going to come this side? This one has 3 hydrogens. Or is it going to come this side? This one has 2 hydrogens. So hydrogen is removed from the carbon atom with the least hydrogens. So this one has 3, this one has 2. So the double bond will form here, and 1 hydrogen will have to be removed. Let's just cancel this one and say this is the water molecule that was removed. This bond is gone. So what compound is this? 4 carbon chains. It's but 1 2 or 1 2. So this is but2ene or 2-butene. Then Roman numeral number 8 states, give the name of the catalyst used in this reaction. So here's the catalyst. So the catalyst is sulfuric acid or hydrogen sulfate, right? Roman numeral number 9 states, to which homologous series does product A belong if it is a major product? So but2ene is the major product and it belongs to the alkenes. And then Roman numeral number 10 states, draw the structural formula of product A if it is a major product. We just did, it's this, right? Remember double bond here. I hope that makes sense. I hope that wasn't too challenging. That's part 2 of elimination reactions, so please take it down. If you found this video helpful in any way, please click the like button and subscribe for more content. Thank you very much, and I hope to see you again.